Let's continue our tour outwards, and now let's look at the satellites of our Milky Way. Here's an image of our Milky Way. Remember that the distance to the nearest star is about a parsec. The distance to the center of our galaxy, from us, our sun to the center, is about 8,000 parsecs. The nearest satellites of our galaxy are the Magellanic Clouds, nearest big satellites. They're about 55,000 parsecs away. Those of you who live in the southern hemisphere have seen these clouds in the night sky. They look almost cloud-like when we look at the night sky in the southern hemisphere. And that's because we're looking at not individual stars, but as we look out towards the large Magellanic and small Magellanic Clouds, we're seeing hundreds of millions of stars whose light add up to give us these faint clouds almost in the southern sky. Those of you who live in the northern hemisphere, the most dramatic nearest galaxy to see is the Andromeda Galaxy. And if you have a pair of binoculars, I encourage you to go out and look at Andromeda. Or alternatively, go to the Hubble Space Telescope web pages and look at the wonderful images that the Hubble telescope has taken of this nearby neighbor of ours. This nearby neighbor is 800,000 parsecs away. That means it takes light about 2.5 million years to get from Andromeda to us. Like our galaxy, the Milky Way, Andromeda also is surrounded by smaller dwarf galaxies. And here's one of the satellite galaxies orbiting Andromeda. If you go to hubblesite.org, there's been a major project with the Hubble telescope that has mapped stars all the way across Andromeda, giving us our most detailed picture of what stars are like and what their properties are in a nearby galaxy. Let's move further out. As we move further out in space, we're actually moving back in time. And this map from the Sloan Digital Sky Survey shows positions of our galaxies across much of the sky. Since we look out in space, we look back in time. It took light about 2.5 million years to get from M31, the nearest big galaxy, to us. When we look out in space, and this is the pattern of galaxies we see, the Sloan Digital Sky Survey has mapped the positions of over 1 million galaxies. Many of these galaxies are 10 million, 100 million, some are 1 billion light years away. It takes light 1 billion years to travel from these distant galaxies to us. So we observe them as they were 1 billion years ago. The further out we look in space, the further back we look in time. We can look all the way out in space to the microwave background. This is the leftover heat from the Big Bang. When we look at the microwave background, we're seeing the universe as it was 13.7 billion years ago. We're not going to talk very much about cosmology in this series, but I do think it's important that you understand a few basic facts about cosmology. The most important one is that our universe and everything we see seem to have started in a Big Bang 13.7 billion years ago. Our solar system is about 4.5 billion years old. So when we look out at nearby stars, some of them might be 12 billion years old, much older than the sun. Some of them are younger. Some will only be 1 billion years old. When we start to think about evolution of life, there'll be some stars where life perhaps has been evolving for far longer than it has in our solar system. There are other solar systems that are much younger. We don't know whether life is there or not, but one of the things we do have is sort of a boundary condition on our thinking is as we go back in time, we look out from the present. When we look out 13.7 billion years, we start working our way back to the very early universe, back to the time when the universe was extremely hot, back to the time before galaxies and stars formed. What's shown here are 2 recent observations of the cosmic microwave background. a lot of my own research has focused on using this data to tell us about the early universe, and then running what we see forward in time and comparing what we see in the microwave sky to what we see in the large-scale distribution of galaxies. But now let's step back and look at the big picture. Think about how big our universe is. We've seen that the distance from the Earth to the Sun, the astronomical unit, while it seems far, is tiny compared to the distance to the nearest star. It's 200,000 times the distance to the nearest star as it is to the Sun, roughly. And these nearby stars we see in the night sky represent a small portion of our own galaxy, the Milky Way. It's about 1 parsec, or 200,000 astronomical units, to the nearest star. It's actually a little bit more. It's about 8,000 parsecs to the galactic center. The nearest big galaxy is 800,000 parsecs away, 100 times the distance to the nearest galaxy. Andromeda is just the nearest galaxy. It's one of many. One of the things we can estimate is the number of stars in our galaxy and the number of galaxies in the visible universe. And there are billions of stars in our galaxy and billions of galaxies in the visible universe. As we'll discuss later in the course, roughly every star, perhaps every other star, contains a planet. So we think there are billions of planets in the Milky Way, our galaxy. And as I've tried to stress in this section, our galaxy is but one of many in the universe. So we live in a universe with billions upon billions of planets. Thanks.